So now we reach the point where we need to analyze the data, and as the software already says, although in the future it's going to be part of the software here, for the time being you need to use a second program, which is this one here. It is relatively straightforward. You press read configuration file, and again you see that it reads where your data is supposed to be. Read the variables file. If you press that, it should go directly to the folder where your data is. You select your variables file, you press open, and it now also tells you that the base file name is this, that it is a variable file type is 1. For future versions the variable file is going to change a little bit, so it could be something different. And I now press fit model to data, and if the annealing scheme is right and if everything is there, it should actually start fitting. So let's see what happens and keep our fingers crossed. There we go. So the fitting is going. It's going very quickly at the moment because we didn't actually set up an extensive annealing scheme. And there you go. This is the sum of square deviations is actually quite high. Output has been generated and it only ran for 11 seconds. But this is what we wanted to happen. And so let's have a look at your data. So because the file that is generated is a CSV file, Windows normally recognizes it as something that can be opened using Excel. So we double click it, and this is our fit. Now it's interesting to see these numbers already. So we seem to have a good interaction, enthalpy, and the stoichiometry. That is actually a bit higher than we initially thought. But the key thing is to go here and have a look at the goodness of fit. So one of the things that we see is that the sum of square deviations divided by degrees of freedom is about 40,000. So it was good that we set quite a high initial temperature. You also have the square over the sum over square deviations divided by degrees of freedom, which is this number here. And this should be individual microcalories, and ideally lower. But because you have this beginning bit of the data that didn't look quite fantastic, that probably explains why you have this number. So now you simply want to have a quick look at what the fit looks like. And you do that here. I'll make this a little bit smaller so that we can probably get everything on the screen. So that's what you do here. So you have your experimental heat. You have your experimental heat effects that were fitted. You also have your calculated heat effects, and you have that as a function of either injection number, total ligand concentration, or of the molar ratio. You also see the weights here, and you see that 0 weight here for the 5 microliter injection, and here. And you see, in this case, this is the experimental heat effect that was not fitted, because the weight was set to 0. So we just want to see this. These are the experimental heat effects, and these are the calculated heat effects. So we just want to see those in one graph. Scatter plot, and there you go. So you see that we do have that little problem at the beginning, but apart from that, we have quite a good fit of to your data. So that looks really good. We can now save this file as an Excel file, because otherwise we cannot keep this graph in there. But that's the first bit of analysis. So that's pretty good. So we'll close this file, and then I'll also show you how to do the error analysis. But the error analysis is probably going to be a little bit problematic because we didn't do a lot of different steps for this particular optimization. Sorry, this is the dilution heat effect, of course. It was this file, sorry. The number of steps that you have and the statistics that you have for this fit is not going to be extensive, but we'll see what it looks like